This video will cover questions 7, 8, and 9 for Chapter 2 on the final exam review. In number 7, we have to graph this function here and then answer the questions below. So I started by just reminding ourselves what the parent quadratic function looks like. Y equals x squared, right? 0, 0 is on the graph. 1, 1 is on the graph because 1 squared is 1. Negative 1, 1 is on the graph because negative 1 squared is 1. 2, 4 is on the graph because 2 squared is 4, and so on. So it might help to think about where this parent function is, because remember, we can think about this as a transformation of the parent function. So one way to think about what our graph looks like is this minus 2 means we're going to take our parent function and shift it 2 units to the right. Remember, the sign is opposite what you think. And then shift it 1 unit up. Right? And that makes sense because this is in vertex form. And we know by looking at these numbers that the vertex is located at 2, 1. So I'm just going to take my parent function and shift everything 2 to the right and 1 up. So this is my new vertex. And so on, just like this. Okay, so this is my function f right there. All right, the axis of symmetry, remember, is that vertical line that goes through the vertex. This is at x equals 2. You need to put the x equals when you're writing an axis of symmetry. It wants to know, where is my function increasing and where is my function decreasing? So it might help to think of breaking your graph up by the axis of symmetry, right? And if you look at your parabola, on the left side of the axis of symmetry, your function is decreasing on this side. And on the right side of the axis of symmetry, your function is increasing. So we want to just state what x values it's increasing and decreasing for. So my function is increasing on the right. So these are values of x that are greater than 2. And it's decreasing on the left side of the axis of symmetry. These are x values that are less than 2. My vertex is at the bottom of my parabola because my parabola opens up. So this vertex represents a minimum. And that minimum value is the y coordinate there. And so that is 1. Or y equals 1 would also be okay. Oops, sorry. All right, moving on to number 8. This one is similar to how we graphed number 7. So the parent function in both 8a and b is graphed, and we're going to graph the new function g of x. And so I want you to think about how was the parent function transformed using the equation of g of x. So remember, we have a negative out here, and it's outside of the parentheses. So this is a vertical flip, meaning you're going to flip across the x-axis or reflect across the x-axis. And this plus 2 is a horizontal shift. Now remember, it's opposite direction you would think. So it's going to be 2 units to the left. Okay? So what I'm going to do is I'm going to imagine flipping this parabola and then shifting it 2 units to the left, or you could shift it 2 units to the left and then flip it. So I know my graph is really, really hard to see. It printed really light, but I'm going to take this vertex and I'm going to shift it 2 units to the left. I'll do the same thing here. I'm going to take this, shift it 2 units to the left, 2 units to the left. I'll do one more so I know 2, 4 is on here. So I'm going to shift it 2 units to the left, 2 units to the left. So here's the parabola before we reflect it. And so now to get my final parabola, I'm going to take this purple one and reflect it across the x-axis. So all my points are just going to be below the x-axis at that same y value, but the opposite. So this vertex, since it's on the x-axis, it's going to stay there. This point will now be at a y value of -1, and this will be at a y value of -4. Okay. I'm just going to be very clear that my green here is g of x, so I'm going to write g of x next to my green parabola. All right, in 8b, if you think about transformations, it takes my parent function and just shifts it 3 units up. Right? I know that's a vertical shift because that's outside of the function, outside of parentheses. So I'm going to take these points and just move them 1, 2, 3 units up. 1, 2, 3 units up. Okay. Number 9. A projectile launched into the air can be modeled with the function y equals -5x squared plus 15x plus 24. This function is graphed at the right, where x is the time in seconds and y is the height in feet. What is the maximum height of the projectile? So we're looking for the y value of our vertex. It's pretty hard to see on mine, but the y value of my vertex here is 35.25. And this is in feet. Okay. Part B, at what time does the projectile reach the ground? So since we're working with the projectile in the real world, we only want to consider time that's positive. So I'm wondering, okay, where does my parabola reach the ground? There's a 0 here, right? That has a y value of 0. It means it's on the ground. And so my time is that x value there. So the time would be 4.155 seconds.